organization is the name of the Aditya Birla, but this organization foundation is going to be led by the our late Prime Minister, Mr. Lal Bahadur Shastri, and then going to hand over in foundation उसको उन्होंने रखी थी, and then जो handed over to Aditya Birla, and then now it is in the hand of the Aditya Birla. So there are the three plants in that power plant: Rayon plant, Caustic plant, and power plant, and that is going to produce 36.5 megawatt power at Delhi. So in the power plant there are these are the main part, that is the hydraulic truck unloader, super conveyor belt, crusher, vibration feeder, screen, magnetic bucket elevator, and the bunker. These all are going to be used in the power plant and coal plant for shifting the coal from the bunker or the coal unload center to the thermal power plant and boiler also. So this is the layout of the coal plant. First of all, we are going to, when the coal has come from the mine, that it is too much bulky and heavy in the side. But in the power plant, they are mainly required the coal at least minimum plus to 8 mm to -6. That is going to be used in the furnace. So you can see here, this is the HTU, hydraulic truck unloader 1 and 2. And from hydraulic truck unloader, this is going to be crusher house. And here the coal is going to be crushed in that fine particle according to the demand of the boiler. And in this process, there are many types of process, and with the help of the conveyor belt, it is going to come at the bunker, which is also known as the storing area of that power plant. Yes, sir. And you can see here, this is the thermal power station. This type of power station you can see here. This is the chimney for the exhaust air, and this is the cooling tower in this type of power plant. Next. So, thermal power plant, there are some extra parts like coal handling plant, boiler and auxiliary equipment, ice handling, cooling towers and cooling water system, and air handling compressor also, because these all are going to be used in the thermal power plant. So if we are not going to use these all things, then the power plant is not going to be runs in the proper manner. So you can see that when the coal is going to be unloaded, that is the size is given there, that is 250 mm and the particle less than 250 mm directly we can use, but there are the many problems with the handling the coal to the bunker house. So we have to crush there the minimum size according to the boiler. Next. So this is the main plant. You can see here, this is the boiler where coal is going to be fed with the bunker to the boiler, and when the coal is going to be burnt, then it produces 3 to 4 types of harmless gases and also flue gas I need also. In the boiler there are if you are going to see the boilers, there are the 2 types of boiler, that water tube and fire tube boiler. And in the water tube boiler, the water is going to be filled into the pipe, and in the fire tube boiler, the fire comes in the tubes, and that is going to be directly heated the steam drum, and then steam is going to be produced. Friends, in this boiler, the coal and air is going to be fed, the primary air or secondary air we are going to feed that coal, and after burning, you can see here the coal is burning, and from downward side the ash are also going to become what? Not full ash is going to become. Some of the ash are going out from the with the flue gas, and flue gas is also going to be heated. There is much heat up to 200 degrees centigrade, and this flue gas is going to be air preheater. Air preheater is also known as the air heating. That atmosphere air is about 24 to 25 degrees centigrade. Before sending this air into the boiler, air preheater is going to be required to heat that primary air before sending into the boiler. If you are going to send directly atmospheric air into the boiler, then the boiler's temperature is going to be gradually down and efficiency will decrease from 65% to it comes up to 55 to 50%. So the air preheater is required. Now the flue gases comes to the air preheater and then come to support burners and baghouse. Baghouse is also going to be connected to the flue gas and extra ice. There are the electrostatic precipitators are connected. If you are going to see the polluted like flue gas and extra ice fly is then also known as the fly ash. The polluted is mainly charged, otherwise it's a negatively charged or positively charged. Here in the baghouse, there are the positively and negatively charged anode and cathode plates are going to place. When the ice is going to be coming in touch of the anode and cathode, then it is going to be deposited on the plate, cathode and anode. Then afterward with the vibrator, with the help of the vibrator, we are going to collect that ice and disposal also. And then flue gas come. There are NOx, nitrogen oxide, sulfur oxide, and H2S and CO2, CO gas are going to be produced when we are going to burn that coal. So you can see that cathode there are reactors. Here that NOx is going to be absorbed. And after all, with the cutting process, the flue gas and now the clean air is going to be sent into the atmosphere with the help of the large chimneys. That's it. So this is the ice handling through the ESP. ESP is known as the electrostatic precipitators. In the earlier slide I showed you that this is the plates. That is the negative or positively charged. When the fly ash is going to become, then it is going to be deposited here. And after it is deposited, then with the help of the vibrator, it is going to be collected and sent into right disposal. Inside ESP, you can see that the construction of this type of controller is very congested, so it is not going to get through any small particle. So this is air preheater. Earlier I said that before sending the air, atmospheric air into the boiler, we have to heat that air with the help of air preheater. In the air preheater there are tubes, and in the tubes the atmospheric air is filled and the flue gas is going to be strike into that tubes and atmospheric air is going to be heated. So it is heated up to 120 to 130 degrees centigrade and then it is sent to the boiler. So in the power plant we are also using the economizer. Economizer means that in the whole process of the power generation, there are too much loss of the water, that is distilled water. So making that the balanced water, we have to use the economizer to heat the water to send in the steam drum. So this economizer is also going to heat the water with the help of flue gas. Here you can see there are tubes. In this tube the distilled water is filled, and when the flue gas, when after burning from the boiler, it is struck to the pipes, and inside the water, distilled water is going to be heated, and then it is sent to the steam drum for the further process. So you can see here that it is symmetrical diagram of that. From coal handling boiler, when boiler burns the coal and then ice is going to be converted in boiler. Coal is going to be converted into ice, then ice storage, and that ice is also going to be sent in some cement factories. So fly ash based cement is going to come in that boiler ice. And there are the collectors, air preheater, that is going to heat the atmospheric air, and high pressure heater, heat pump that is going to be used in the turbines, not turbine, in the steam drum, condenser extension pump. First of all, the water is going to be heated, then it comes to the turbine, and turbine the steam is at the high pressure and high temperature also. It's about 500 degrees centigrade heated, that superheated steam and when it is going to be stacked with the turbine blade, and blades is going to be rotated, and that turbine is attached with the shaft, and shaft is attached with that generator and electricity generated. After striking the steam, that is its pressure is gradually going to be decreased. Pressure becomes at 100 bar, like something that, and temperature also decreases, and then the steam is sent to the condenser. Condenser cools that steam to feed into the steam drum for the further continuous process is going on, and then generated power is going to be sent by power transmission tower, and our home also you are using that, and extra unwanted things are going to be thrown out the atmosphere through the chimney. So this is the process of steam formation. Simply we are going to see that the coal is heated, coal is burnt, and heat energy is going to produce, and it heated the steam, distilled water, and it is going to produce steam, and steam is also further, after further classification, that is going to become the superheated steam, and then send it to the generator, and electricity is going to be generated from the coal to electric. Because that is a thermal power plant, you can say. This is the inside the boiler, you can see. This is the steam drum. It is half filled and half it is kept at this space. Here, at the half area, the steam are going to be stored. When the boiler, once the coal, you can see that the water is filled with the distilled water, and when water is heated, the bubbles are going to be formed, and that is steam formation, and then high pressure when created, then it is sent to the turbine, and there are safety valve also if the unwanted, no, here is not safety valve, filled water pump. That was the steam turbine that you can see that this was the it was the multi-stage turbine. So in this area there was the governor, that loaded governor. It is going to be converted with the operated with the steam, and this is area of the governor, and this is the turbine, and this is gearbox, and here that is the generator. You can see that was the horizontal impulse multi-stage multi-wave axial flow condensing expansion with the that the rate output to the 20,000 kilowatt operating condition. You can see that the speed is 6,200 rpm, inlet steam 87 kg per centimeter square, that was, and temperature 505 degrees centigrade. Exhaust steam that gradually increases up to 0.1 kg gram per centimeter square. Yes. And this is the internal structure or construction, we can say, that of turbine. Here going to see that the construction is going to be decreases gradually. High pressure steam is going to be stacked here, and then the pressure is also decreases. So the blades construction are also going to be decreases, and then from inlet to outlet, that is the internal construction of the turbine. So after, when the steam is going to be passed from the turbine, then the steam is going to need that cool. So you can see this is the cooling tower of that power plant. They were using this types of cooling tower to cool the steam and then feed it up to the steam drum.
कर दे तो कर दे.
This is the condenser.